Welcome everybody. It's nice and cozy room, so we can literally have chat and you can ask questions anytime while we are presenting. I'm Komal Mangtani. I am engineering director for VMware Application Management products. Have been with VMware for 5 years, and before that Oracle and BA WebLogic systems. So kind of sitting at that unique junction of applications and virtualization technologies, which makes it all very interesting. And with me, I have my teammate, Matt Ford.
So I've been with VMware for like 7 years. I've been working on basically a lot of tools for developers, actually enabling people to actually use virtualization for their applications. So I've worked on a product called VMware Studio for a few years. I don't know if anyone's heard of that. But then in the past few years, we've been working on a product called VMware Application Director, which is what we're going to talk about today.
Wow, it takes time to refresh. So we have kept the agenda very short and crisp. We want to talk a little bit about the ongoing trends, not too much one slide, around cloud operating model and the DevOps model and how it's impacting the traditional application management. There will be a brief introduction of Vfabric Application Director, and then we want to jump into the core of our talk, which is around Puppet and Application Director, how it comes together to enable IT administration in a new way, in a cloud, in a way where you can move your applications even in cloud environments. So we'll talk. We'll also see a demo. Matt has some demos for you, and that would make it more interesting. So with that, let's talk about the new cloud operating paradigm. With the advent of public cloud and this ability to get capacity easily from public clouds, we see a new trend here where there is a set of cloud providers sitting with infrastructure capacity and managing the infrastructure, while at the same time you have application developers or cloud consumers who are consuming this capacity. And there is sort of a brick wall being formed between the two, since purely by the fact that the cloud consumers cannot be sitting next to that public capacity. You don't know who is your IT administrator in Amazon. You are using the infrastructure of Amazon. So with that example, you can see that how cloud consumers, the application developers, are sitting away from the actual infrastructure. And that, if you step back, it makes you think a bit differently how the traditional application development has been going on, or traditional server-side development has been going on. And we'll talk about that in a minute. But while these two silos are getting created horizontally, there is still a need for them to talk to each other. The infrastructure administrators, they need to know what kind of load is going to run on their infrastructure. At the same time, the application developers would like to know whether the cloud they are going to, or the infrastructure their app is going to run on, is it going to provide enough capacity, provide enough security for their applications. So there's still that need of visibility between the two layers. And while these horizontal silos are being formed, we see some vertical groups coming closer to each other. We see this much with the software as a service vendors, where the application developers and the application operators, the people who are releasing that application, deploying that application, and then managing it as a day-to operation and so forth, they are coming closer to each other. And in extreme case like Facebook, it's actually merging. The two functions, the app development and app operations team, are actually merging, where you sometimes find the developers themselves pushing the code. While at Facebook may be an extreme case, there's still this notion with software as a service providers, where developers are asked to take a little bit more than just developing their apps and pushing it out. So we'll see how these two trends are impacting our thoughts on how traditional app management is being done. So here's a slide on, let's see how it used to be, and maybe it's, in many cases it's still the case, where it's a very bottom-up approach. When you are deploying an application, you start with first provisioning your servers, Then your OS, before that you have configured network storage, so forth. After that, you think about your application stack. And finally, you talk about that core business logic, that core IP that your application is going to carry about. You think about it the last when it comes to provisioning. Now, when you see this model, it doesn't actually fit into the new world, where first of all, you don't have your infrastructure next to you. And with the advent of PaaS environments, you are getting that application stack also laid down. So what it requires you to do is a more top-down approach. First, start with your app. What does your application require? What kind of middleware infrastructure, the server compute network capacity does it require? So start top-down and think about the app and then its underlying infrastructure. So we see that with the change in with the advent of this cloud operating model, the public clouds, you are now required to think top-down. It's not something that I'm preaching here that we should be thinking top-down. It's something that is naturally happening with the models that are available in the market today. The second change that I'll be talking about is the day two operations. So you deployed your application. Bottom up, top down, you deployed your application. Traditionally, you have deployed the app, you have put some monitoring tools, attached the monitoring tools to your application, and now you are gathering some statistics around your app, how it's performing, and hey, how much CPU memory is it using, and you get, sometimes it gets a little bit deeper into the code to know which part of your middleware infrastructure is not working. But you get this basic information, and when something goes wrong, you suddenly start guessing what's going wrong. You have war room meetings, and then you get some basic data, make some assumptions. They might be false, but that accuracy of solving that problem is quite low. You are not able to pinpoint accurately where exactly is the problem. Now, if you see the new world, where we see the DevOps coming together, if you sit back, the interesting trend that is happening is if developers are required, as a developer, I'm thinking if I'm also responsible to think about the day two operations, if I'm also now going to be worrying about how my app is going to perform, not just developing app, but also how it's going to perform once it goes live, then why not put some rich monitoring semantics within the app itself? See, I'm in control of my code. Let me put some more troubleshooting information in the application. Let me put some more monitoring constructs in the application so that when something goes wrong and I'm called, I know which logs to look for, what data to look for, and I have that information. So with the dev and ops coming closer to each other and sometimes being the same function, there is a need for application management tools that provide you that closed lifecycle, very integrated lifecycle, where the same tools that deploy your app allow you to monitor the app and update the app based on that monitoring information. So with that, we in VMware have been thinking about how do we manage our application workloads, the workloads that run inside our VMs. And while we have been thinking about that, we see these trends, and we based our strategy, the core strategy of our products, on three key axes. The first being we have to enable that public cloud model. We have to enable this public cloud model. We have to provide tools that can help you describe your application requirements without knowing where it will land. Because in dev and test, it may land in a private cloud, or rather in dev test, it may land in public cloud. In production, it may be landing in a private cloud. So how can we help you define your application without knowing where it will actually land? So that is one key axis. The second one is we have to have that closed loop that we just talked about, that the same set of tools that help you provision an application can help you monitor, can help you gather more data during monitoring, can use that monitoring information to then perform updates or ongoing maintenance. And then overlay it with security information, compliance information, and so forth at an application level, not an infrastructure level. And the third axis is, while we are doing these two pieces, we want to make sure we enable our products for any type of applications. not just for tomorrow's app, where we see PaaS focusing on, not just for yesterday's apps, where we see the big four in management, the big four management vendors focusing, but how do we create that generic framework that can enable you to manage your applications that were either written in C, C++, or written in JEE, or maybe they are written in using Django or Python and so forth. So with that, when you look at our products, our application management products, this picture would help you if you keep this in the back of your mind, because this is what we have been thinking about all the time. So the goals for our products. First, we started this product like I think 2 years back, and we could have very well said that let's envisage the future and let's make sure we develop products that satisfies only the needs for for stuff that is going to happen 3 years down the line. But that was not our goal. We wanted to make sure that while we think through the future goals, the future market trends, we also consider the existing trends. What is IT administrators, what are they facing today? What problems are they facing today to manage their apps? So we kept that as our first thing, that we want to accommodate today's enterprise needs. And this is where we'll drill down into details around how we bring in tools like Puppet, Chef, CF Engine, and so forth. How we have created a framework where we can easily integrate with this kind of existing tools that are already prevalent. The second goal was model-driven management. So when you see application management tools, sometimes you see them following a very strict workflow automation, where you're describing each step in your runbooks, you're describing it as an orchestration piece. And we decided not to take that approach, and rather go with a model-driven, where you describe your application dependencies to the system, and then system can keep track of those dependencies. And system can tell you if a dependency is going to break because of an update or so forth. The third key goal we kept for our products is keep the cloud, the richness of cloud, keep that separate from application. By that what I mean is, once you define your application, you can decide which cloud you want to deploy to, and we will invoke a cloud driver specific to that cloud and leverage the features of that cloud, say Amazon or vCloud. Of course, vCloud is our first cloud driver we would go out with. But we are also coming out with Amazon in this release. We just did beta and so forth. So how do we enable that layer where people can write their own cloud drivers? Because the other trend we are seeing is that in many IT organizations, they are developing their own custom cloud, at least their custom cloud layer, that can then talk to not just vSphere clouds, but it can also talk to Hyper-V and so forth. So they're creating that custom cloud layer. And how can we enable you to leverage that investment you are making by allowing you to just write a cloud driver that then talks to your own custom cloud. We introduced 2 products around application management. Earlier this year, we introduced Vfabric Application Director, which is our main product, which is the lifecycle management of applications. It starts with provisioning and updates and performing all your operations on your application. And then there is Application Performance Manager that works closely with Application Director to do the monitoring of the same application, and it understands and views the application in the same form as Application Director. We'll drill down in the first, we'll keep this presentation to the first goal, because that's where we want to show how we leverage, allow you to leverage Puppet with Application Director and so forth. So drilling down, double clicking into that first goal, what do we mean when we say that we want users to leverage their existing infrastructure, their existing system, their existing processes, along with our new product? Before I go into Puppet, there are various things that we see. One is people have existing scripts which they are already using they have the best script written to how to deploy WebLogic. They have one of the best scripts written how to manage Oracle database. We want you to, in Application Director, you will see a framework that can help you plug in those existing IP. The core IP that you have in your scripts, you can plug them right into Application Director and use them. If you don't have that, It's not just a generic framework that the product brings in. It provides rich out-of-box content. So as a jumpstart, you will get WebLogic installations and configuration update scripts from us. You will get scripts for entire Vfabric suite, of course, from us. So you can imagine the product sitting at that junction of Vfabric suite of products from VMware, as well as our cloud infrastructure products. And now you can imagine where I'll take it when I talk about Puppet. When we talk about Puppet, I many times get this question, is it your competition? Is it complementary to what you do? If I have Puppet, then do I need Application Director? And so forth, right? What is the deal with Application Director and Puppet? So I thought this slide would help, and I just posted a blog today morning, so it would be interesting to read that one too. But if I try to summarize in 3 key points about how they work together. Firstly, it is a very complementary technology. Both the technologies work closely with each other. In fact, we started Application Director after, when we started Application Director, these tools, Puppet, Chef, and so forth, they were already existing. So we already knew that we have to work with these technologies. We want to leverage their strengths. And the way we view it together, Luke and I were talking quite a bit about how we position this together. And it was very clear that application lifecycle management, the Application Director, is providing an end-to-end solution. What it is providing you is a solution which goes and provisions VMs, OS, Puppet agents, everything, till the point where you have to tear down the whole VM and the whole setup because it was dev test, or in the production you have decommissioned the apps or whatsoever. So Application Director is this overarching product which is helping you create, deploy your applications right from point zero. And now, Puppet, as we all know, Puppet comes in when you have configured OS to a certain point, and at least you have installed OS, let's not say configured OS, but installed OS, and then you put Puppet agents on it, and then you start deploying components on each machines using Puppet that connects to its repository and so forth. So we have this framework which Matt will be showing in actually in Works, where you can plug in the Puppet modules into Application Director for specific app components. Let's say you're deploying WebLogic database, WebLogic Oracle database, and an Apache 3-tier application. Then we will help you deploy the whole application end-to-end, leveraging the Puppet modules for WebLogic, for Oracle database, and so forth. The second thing is Application Director is very much app aware. It talks in terms of application. It understands apps. And for app, by app I mean the app can span multi-machines. So it may not be restricted to one machine. It may be involving multiple nodes. But traditionally in past, of course, Puppet has been taking more a bottom-up approach. Even now we see Puppet taking more bottom-up approach, where you start thinking about your machine configuration, whether it's compliant or not. And it's working against a repository to make sure that each machine is compliant against that state. App Director comes more top-down and says, here is the state of your overall app. So that way they again complement each other. And the third piece is, it's kind of different goals for both the products. Application Director is more meant as an automation release tool, where it helps you take your application from dev to test to stage production, while using the Puppet scripts along the way. But it is more of a release automation tool versus a configuration management tool, which is where Puppet comes into picture. So with that, I am going to hand it over to Matt. He's going to talk about some touching concepts, the concepts that touch with Puppet, so that you can make most out of the demo that he's going to show.
Sure, thanks, Komal. So we have a few slides here that I can go through first to kind of get a little background before I jump into live demo. Live demos always crash too, so just in case. So essentially what we have here is actually, when we log into App Director, you have more or less an overview of a lot of things. So what we're actually showing here is a set of applications that are inside of App Director. And it might be a little hard to read, but for example, this is a Zimbra application. So this one right here will deploy a Zimbra application that has 5 to 10 VMs in there, in a cluster configuration and so on. So the different apps you can have in a different thing. So one of the things we'll get into, like in the live demo, is actually talking about the logical model. But once you have this logical model, we call that a blueprint, you want to actually deploy it, and you choose like where you're going to deploy it to. And so, as we mentioned earlier, there's like you could use vCloud Director, Amazon EC2. In the future, it's open. We can always add additional clouds. But the point is, like, you modeled it once, and then you would say, okay, I want to actually select what cloud to deploy to, and then maybe we just want to say, okay, during this deployment, we want to override a few properties and the configuration details. And so you can create this thing that we call a deployment profile, and you can have many deployment profiles on each of the apps. So you could say, for my Zimbra app, I want a deployment profile that deploys it locally, and it only has a cluster size of 1. But when I deploy it to EC2, maybe I want to deploy it with a cluster size of 50. Maybe that's my environment. Okay, so when we get into the details, when we start talking about how to model, we're talking about, okay, the model has information about the operating system. Like, what is the OS? And so you're going to have like 10 VMs, and maybe one of them needs to be Red Hat, one of them needs to be Windows. And it could go on. But then on top of that, you also have a bunch of other things. Like, say, we need Rabbit on this guy. And there's also relationships between all the different pieces. And so you could say, okay, so we have Apache, we have Rabbit, we have a database, and so on. And you have all the relationship information between all the pieces, all the properties, all the configuration. And then eventually, when you drill down enough, you'll have like all the configuration type of pieces. And so what we do is, before building a blueprint, you need to be able to define all those pieces. Like, what does it mean to be a Rabbit, right? So what that is we call that a service. And so we have, in App Director, we have a catalog, and you would define the different services. And so here, it's a kind of example. We have web server, app servers, messaging servers, in-memory database servers. But those belong in the catalog. A catalog administrator can go in and define how to install Apache, how to install MySQL. And then that's what actually gets into the logical model of the blueprint.
So just to interject, but these are the left-hand side services that you see, that could be coming from your Puppet form. These are the Puppet, this could be Puppet modules that have Application Director wrapper over it. And you'll see it in details as we go along.
And so, kind of like Komal was mentioning earlier, as a developer, maybe you want to deploy things locally, but in production, maybe you want to deploy it to some other environment. And so that's where the deployment profile comes into play. But once we actually have the deployment profiles, we can deploy it many times, and that's where we end up with deployment. So you could take that Zimbra application we talked earlier, you create deployment profiles. One is for your local environment that only has 1 or 2 nodes, and then you have your EC2 environment, that's a different profile, and then you could have multiple deployments of the same app. That's where we're getting at. So it's kind of the same model. Maybe you have your test in production. It goes out to the same thing. But the key point to point out is you have the one logical model that has deployment profiles, which are essentially mapping it to where you want to go to, and then eventually you end up with multiple deployments wherever they are, maybe. Okay, so here's a screenshot of what it means to actually create that logical model, the blueprint. And so earlier you saw that we have kind of the OS. That's what is represented by the gray boxes. And then there are all the services that actually get dropped into it. And so you can see on the right-hand side, we actually have a list of things that are coming from our catalog. And those can be dragged and put onto each of these nodes. And so here is kind of like a web server it's kind of hard to read, but there's a web server, a rabbit, and so on. So those all came out of the catalog. They get placed into the blueprint, which is a logical model. And there's a few other things to kind of point out here. When we get into a live demo, I can get more details. But the key things are, if you follow these blue lines, these are dependencies. So you can have relationships between the different pieces. So you could say, your app depends on your database. And then you can actually share the configuration between the two. Like say your database has the port configuration, and your app needs to actually know what port to connect to on the database. You can share that information with the properties that bind to each other. And we'll show that in the demo. So one of the things to think about is that the logical blueprint is really abstract from where you're actually deploying it to. And so even though you saw those VM templates, one was Smart sent to us, one was, it could be Red Hat, one could be Windows, that's not really pointing to anything specific yet. It's when you actually do the deployment that you actually map to a specific thing. And so that abstraction is what allows us to have this logical model that has multiple deployment profiles that are kind of separated this way. So when we talk about the properties, there's a few things we should say. So when we define a service in the catalog, we will say, okay, Apache, or say my database, let's get back to the database. It has that port information. So maybe the catalog administrator will define MySQL and say the default port is 3306. But in the application blueprint, maybe for some reason they decide to run on port 9000. So they can override at this different level. So there's like a scoping of properties. And it also, when you deploy it, you have the ability to override it as well. So there's like these different levels of scoping of properties. There's also a few property types. You could say, obviously if you're doing like a load balancing situation where you have like a cluster of nodes that you're going to load balance over, one of the properties that you could use is a cluster of the IPs of load balanced app servers. And so that's something that can be passed into the Apache. And additionally, say if one of your services is generating some sort of key and it needs to be passed to another key, one service could actually create a property, it could have a property where it generates values and actually passes it into a different service. And so the properties can bind to each other, they share information. And so when you think about the blueprint, it's not just install these pieces, but it's really these pieces and how they relate to each other. So that's the key part. This last piece right here, the pluggable script engine. So we support different OSs like Windows, Linux, and inside of that, like if you think about, we have one framework, one blueprint. You can mix Windows and Linux. There's no problems. The way we actually are able to do that is we abstract the idea of what a service does down to a type of a script. And so on Linux, generally you're going to run like a shell script, and of course that can invoke anything else. But on Windows, we support things like PowerShell and so on. Okay, so actually we're jumping a little bit. So once we have that blueprint, then we're going to say we want to deploy it. We have, I think it might be easier to see when we actually do the live demo, but essentially we're picking a place we're going to deploy to. So we're picking the deployment environment. And then within that deployment environment, we're mapping those VMs. And so here we're saying, okay, the web server VM, we know it's already supposed to be a CentOS VM. And on that cloud, we know we have maybe 2 or 3 options for a CentOS VM. So your deployment profile can create this mapping so that when you deploy to EC2, you know exactly what should be there. When you deploy to your local cloud, you know what images you should use there. Additionally, one thing we haven't seen yet is the network configuration. And so inside that blueprint, you could say, your load balancer is on 2 networks. One is a public-facing network, and one is your private network. And the rest, everything else inside that application could be on that private network. And so this way, you're actually able to map it here. You're able to say, okay, what is my public network? And if you're using vCloud Director, you're able to map it that way. If you're using Amazon EC2, they have a little kind of tricky way to do things with networking that we can say we can actually create these kinds of things. So once we go and we decide where we're going to go, we've done that mapping, we generate basically an execution flow, which is like a run book, right? So what are the specific steps to actually install the application? And so when you create your MySQL service, you need to do the installation, and then maybe you need to do some configuration and so on. And so this is essentially what we end up with, is this execution flow, where we have all the specific individual steps that have to happen to actually install those pieces. So now I want to talk about how we can actually use Puppet in here. And so essentially what Puppet has done is, one of the things they did is they created a script to actually help in this. What it allows you to do is take a Puppet module, run a utility on that Puppet module, and say generate a service script for that. So you could say generate a service script for MySQL, and then you take that script, drop it into the app director, and then you have a MySQL service in app director that uses Puppet to actually do its installation and configuration. And that's what we'll talk about. So we'll talk about this right here, and just kind of jump over to live here. This is where everything usually breaks, so. Okay, so I have essentially an app director that's running, and you see this is a lot of the same what the screenshots you saw earlier are. But let me open up an example here. So we have a 3-tier application that's sampled. It's called Duke's Bank. It's kind of an existing, very well known, I guess you could say, just as a sample. But I'm going to open up the blueprint for this, and we'll talk about the pieces. So this is a simpler one than we saw in the screenshot. Basically, we have Apache, and then we have JBoss, and then we have MySQL being installed with Puppet. And so we see there's a simple relationship between Apache and the Duke's Bank application, and the Duke's Bank application is running on JBoss. And then we see that the application has a relationship with the Puppet, or the MySQL, which is installed by Puppet. And so if you take a look here, we can see this is in a clustered configuration. And in the blueprint time, we're able to set the cluster size. It's set to 1 here. But we can change this, do deployment, and that's what we'll get. So earlier we talked about properties. And this is where I want to, where it's really useful to kind of have live stuff. So if we look here, I highlighted the MySQL service. And here's a set of properties that are applied to the MySQL service. If you ever installed MySQL, this is kind of basically what you'll see. You need database passwords, you need database name, what port to run on. So let's take a look at the database port specifically. It's 3306. And so we defined it in this blueprint as 3306. And then we have our application. We can take a look here. And we actually bind to that here. So if we scroll down, it's going to be something like this. And so it's a little bit hard to read, but you can see that the blueprint value is set to the database, the MySQL port. And so what happens is, actually, we don't necessarily know on this service what that value is until it's actually running. A better example for this case might be the IP address, like the database host. So until we actually deploy this in EC2 or wherever, we don't really know what the value is, but we do know that relationship, that information. And so that's how we're able to bind with each other. There's a few other things that we can apply, like whether properties are required, whether they're secured, whether you can change them during the deployment time, those types of things. But we have a kind of a rich library of that. But now say that all this information is set, and we want to actually do the deployment. Essentially, this is where we go. And so you'll see, we go through the exact same things that you saw earlier in the screenshots, but we can kind of see it live. I'll choose an existing deployment profile that we already have set up. And in here, I have the ability to actually choose like which environment, like you saw that in the screenshot. And we can map it and so on. So we talked about overriding property values during deployment. So right now what we're doing is creating the deployment profile for that application. And here we're able to set, for this deployment profile, I want this VM to have, these types of properties, how much memory, how many CPUs, and so on. But we also have the ability to drill into all these other pieces. So for the service, we can say, for MySQL, for this deployment profile, maybe I want to run it on, the port 9000. So we have that ability at this time to override it. And so the key thing is the blueprint model doesn't change. It's just at this level. So once we get here, this is where we're generating that run book or the execution plan. And so you can see that this is actually a generated flow. You can see for the app server, we have to do the install configuration and so on, and the same things. And you can see like this is a little bit hard, but the transitions between the different pieces. And so you can say you're going to transition from this task in this node to a specific task in a different node, right? So you can do these like relationships between those. Now, one other thing to mention, like on the screen, is that so far we've done kind of like the application level stuff. We know what the application should look like, but we always know like when you deploy something to a certain environment, maybe you want to put something on that. Like maybe you need to apply some firewall rules, or maybe you say in this environment you need to connect to an external load balancer or so on. So you have the ability at this point to actually add what we call a script task. And so in this case, I'm just going to randomly place this guy. And I have an example here that's actually using Puppet to set a specific password for root and change the SSH configuration to run on a different port. And so you can have this custom script task and say when you deploy it to EC2, you always want to set your root password to some value, and maybe, or you could set it randomly, it doesn't matter, and maybe you want SSH to be disabled. That's a possibility, versus using the same logical blueprint and deploying locally. Maybe you want to leave your VMs open. And so you can actually make these kind of policy things at this time, these kinds of decisions. So once this is done, essentially you can actually go and start a deployment and deploy it. I'm going to just click deploy, but then once this starts, so essentially what's happening now is it's going out there, it's going to the cloud, it's deploying these VMs, it's going to start doing everything, installing and configuring it. So,
can you guys a little bit more detail on that?
Okay, so which level, like what piece do you want to see?
So what's your interaction with Puppet?
Okay,
so
yeah.
There's that application module, and you're just injecting all these values into the
Yeah, so I'll jump right into it right now. So in fact, I have an older deployment that that's already done that we can kind of drill in to get more details. So I have this guy that I set up for this demo. And so what happens, like we can actually go back into this execution plan and see what happened after, or you can actually watch it live, but you can actually come back later for debugging or any other purpose and see what actually happened. And so you can see all the different tasks. And so we did these types of pieces. And so let's kind of to answer your question, let's see what actually happened here for the MySQL install. So earlier I showed you on the blueprint editor the set of properties, like how it was set here. And then what ends up happening is it runs a script that does essentially creating a Puppet manifest, and then using Puppet to actually.
I see.
Yeah.
So it runs locally on the system as if it was the Puppet master itself locally to just apply a catalog that you already have.
Yeah. And so the only requirement for this is essentially you have to have an agent, basically the Puppet agent installed. And so we have another service just on here to make sure the agent's installed. If your template already has the agent, you don't need that. But that's how that works.
So can this integrate with Puppet Master?
So I don't see any reason why it couldn't. I mean, I think the question, it kind of leads maybe to like who's in charge later on, right? Who does the updates and so on.
Yeah,
and
so
so
I think the main concern would be to control drift of the system later on.
right.
And we'll touch upon it a little bit, but I'll be honest and say that we are working out that part, the update part. Of course, there's always one answer where one takes the lead.
Yeah.
It seems to me that your whatever piece you add to your catalog, instead of a last go install, it can be a Puppet client config script that runs, which
Yeah.
connects it to your Puppet server and hits whatever that defines that.
Absolutely, definitely.
Yes, that is one way of looking at it, and that's what we have been thinking in so far. But there is also the other aspect of because Puppet has this more rich features around its own orchestration mechanisms, and how much will we lose that if we just go down this path? That's what I've been working on.
You still control drift on the master side by having like a lot of the classes defined by like a part of the name, like with expressions and stuff to say that if it would match this IP or something like that, be a factor, it was allowed to continue to do this update stuff just a little more.
So one of the things, let's talk about another, like, once you've actually done the deployment, later on maybe you want to come back and do an update, like maybe you want to change the scale, like scale out a node, or maybe you want to change that port number, for example. So one of the things you can do is jump into update, and you can do like a change configuration. And essentially what you'll do is create another deployment profile that's an update profile that will allow you to do so what you can do here, what I'm doing is I'm creating an update profile where you can go through and actually change the configuration. And so what happens is that, like you saw an installation script for like MySQL, but you can also have an update script that knows how to go back, and in Puppet's case you would reapply a manifest, but you could do like any shell script, for example. But the key piece, I have another, actually, yeah, go ahead.
We are also running short of time, so if you want, what we could do is point them to the booth
Yeah.
and take the second demo there,
Okay.
because we should be wrapping up